So let's talk about implementing logging in a microservices architecture. Now, as we said before, logging should provide a holistic view on the system. It should allow tracing end-to-end flow, and by end-to-end, we mean from the service where the flow originated to the service that ended it, with all the services in between included. Naturally, logging should contain as much information as possible. You can't really have too much information in logging, so make sure to log whatever data you can think of, even things that at first look might seem useless. For example, you definitely want to log at least the timestamp, severity, module, message, machine name, perhaps even IP and port. Whatever you can think of, use it. In addition, when viewing the logs, you must be able to filter the waterfall of data using fields such as severity, module, time, etc. For example, you might be interested in seeing all the errors that occurred on the orders service in the past 4 hours. So instead of sifting through all the raw log records, you must be able to quickly filter the data to show only what you really need. Now, logging in microservices architecture should work quite differently from the traditional logging. Let's take a look. In a traditional logging, if we have, say, 2 services, then each one of them has its own logging infrastructure. The service is using its own logging library, and the logs are written to the service's own repository, be it a file or a database. This is quite easy to implement and has become the most popular way of implementing logging, and for a good reason. When our application is composed of a single process, there is no problem with such implementation. However, with microservices, we have some problems implementing the logging like that. So what are the problems? Well, there are a few. First, this means the logs are separate from each other. If we want to look at the logs and trace an end-to-end flow, that would be a problem. Next, using different logging libraries means we might utilize different log formats, and so we will get one log file where the data is stored as JSON document, and other one where the data is stored as a regular text. This will make going between the logs confusing and slow. In addition, the logs are not aggregated, meaning we can't have aggregated data on the logs, such as how many errors were in the last day, or how many database accesses did we have. In order to know these numbers, we have to have all the log data in a single central place where we can run these queries on, but that is not the case here. And lastly, the logs can't be analyzed. In order to analyze the logs and generate insights from them, we need to be able to have all the logs in a central location that can be analyzed. And again, that's not the case here. Okay, so we looked at the problems, but what should we do to handle them? Well, here is how we should implement logging in microservices architecture. Again, we have our 2 services. Only this time, we have another one which is responsible for the logging. And now, whenever the services want to log something, they write it to the central logging service. This way, we have a single location for the logs, and it looks like we handle the problems. So let's see. Our logs are now unified and are all stored in the same location. This means they are aggregated and calculations can be run on them. And also, they can be analyzed. By storing all the logs in the same location, it's quite easy to query the logs and extract meaningful insights. Okay, so it's clear this is the approach we want to take with logging with microservices. But now we need to see how exactly this approach can be implemented. And when looking at the diagram, we see there are 3 places we need to discuss. First, the logging library. What should we use in order to generate the log records? Is there any special requirement? Next is the transport. We need the logs to be transported to the central logging service. How should we do that? And lastly, the service itself. How should we build it? Should we use an existing product, build one of our own? So let's see. And let's begin from the logging library. Now, the recommended approach here is to use a single library for all of the services. You can pick any library you want as long as it's flexible enough and suits the development platform you use. For example, you might pick Winston for Node.js apps or Serilog for .NET Core. Both are modern, fast, and extremely flexible libraries. Now, If your system uses more than one platform, which as we discussed earlier is completely valid in a microservices architecture, then pick one library for each platform. For example, don't use nlog for one .NET Core based service and Serilog for another. There is no point in that. Another important aspect of the logging library is to use the severity field wisely. As a refresher, the severity field defines what kind of event is represented in the log record. Severity usually begins with debug, which represents an information that is of interest for us only when debugging the system, but not on a regular run. Then we have the info severity, which is used to log events we should be aware of, but are not a reason for concern, such as system startup or something similar. We then have the warning severity, which indicates there is some kind of problem, but not one that we should really worry about. We do need to keep an eye on it, but no more than that. And then we have the really bad news, error and critical severity, which tells us something really bad happened and the system might go down any minute now. So make sure to use the severity field wisely. Don't fill your logs with info messages that really contain debug data, which is one of the most common mistakes junior developers do. And also, don't log errors as info, which will make them invisible to the monitoring tools. Now, another thing to keep in mind about logging is the info to include in the logs. And the rule of thumb is quite clear here. Log as much info as possible. This means logging at least the following data: timestamp, which is the exact time the event happened, the user performing the action, the severity of the event as we just discussed, the service this event happened in, what is the message or the event we want to log, for example, new order created by user 15, the full stack trace if we log an error, and this is one of the most important fields here, the correlation ID. And I want to talk a little bit about this last field. So what is correlation ID? Basically, correlation ID is a flow identifier. It correlates events between services and so enables stitching separate events to a single flow. I know it might still sound quite obscure, so let's look at an example. So here is the logging architecture we discussed earlier. We have the two services and the central logging service. Now, the red service sends a log record containing all the usual suspects with the timestamp, user, severity, and so on, but also a field named correlation ID with the value 56. Note that the correlation ID value is completely arbitrary and can basically be anything as long as it's unique in the system. And now the second service sends log record with the regular values and also with an identical correlation ID, 56. Now what happens is that the logging service has two log records. One logs the flow start and one logs the flow end. And when we look at these lines, we can conclude they belong to the same flow. How can we know that? Because they have the same correlation ID. And that's the role of the correlation ID. By using the same correlation ID across services in the same flow, we can then filter the log by this correlation ID and see a full picture of the flow. Okay, so this was the correlation ID, and now let's move on to the next element of the logging architecture, which is the transport. Remember, the transport engine is the part in the logging that transports the log from the services to the central logging service. As you can guess, it has quite an important role. Now, usually, we would prefer using a queue for such transport. Queue balances the load that might be applied on the logging service, and it can function properly under heavy load. In addition, there is no performance hit on the client side. The cost in time and computer power of pushing data into a queue is negligible and is definitely much lower than writing to a file. Now, which queue engine should we use? Well, it doesn't really matter. There are a lot of queue engines and you can basically use whatever you want. However, the most popular ones are RabbitMQ and Kafka, and I would highly recommend picking one of these. I personally prefer RabbitMQ due to its simplicity and flexibility, but feel free to pick any other option. Next is the logging service, the central component that receives and stores the log records from the other services in the system. This service is preferably based on an existing indexing, digesting, or search product. These products are designed from the bottom up to handle a huge amount of data in various formats and to make this data accessible using easy-to-use visualization tools and query language. In addition, such product can usually index almost any log format, regardless of its structure, file format, encoding, etc. Most tools provide great visualization of the data, and best of all, they don't require development at all. There might be some configuration required to configure the receivers and formats, but basically, that's it. So, which tool to use? Well, the most popular tools are the ELK stack and Splunk. Both are popular, both are very powerful, both can access a lot of data sources, and you can't go wrong with any of them. I personally prefer the ELK stack, but Splunk will definitely do. Okay, great. So that was about logging in microservices architecture, and now let's move on to the next topic, which is monitoring.